Okay, example 10.2D. So if you'll see, this has got a lot of different things here. However, there is one key thing we need to look for. There is something in front of a set of parentheses. This can be done with distribution. So this is going to make these problems a lot easier. So what we're going to do first is we are going to distribute this. Notice again, I equals 1, so this is going to be a good problem. It's not going to be as hard to solve. But we've got to distribute this whole thing to each individual term in here. So when we rewrite it, you should notice we have 3 problems that should be easier to solve. Now, with these first 2 problems, there's one thing I have to do. I can't do these with this right here. It's similar to the logarithm. When you have an exponent, you have to take it out front. For this one, when you have a constant with the term, you have to take it out front. Okay? And I'll show you what we do with those afterwards. So we're going to rewrite them one more time. And if you'll notice here, we've got consecutive squares, consecutive numbers, and constants. So from this, we are simply going to plug in our formulas for this. I equals 1, and they're going up to 10. So for this one, I'm going to do 2 times 10 times 10 plus 1 times 2 times 10 plus 1. All of that over 6. Then I'm going to subtract 3 times 10 times 10 plus 1 over 2. And then for this part, since it's just a constant, I just get to do 8 times 10. Okay? So for this problem, we're going to set this up. We're going to have 2 times 10 times 11 times 21. All of that over 6. And then we're going to subtract 3 times 10 times 11 divided by 2 plus 80. Okay? 10 times 11 is 110 times 21. Okay, so we've got 2 times 2, 3, 10 over 6 minus 3 times 110 over 2 plus 80. Okay, and when you get down to this simple math, okay, then this becomes 770 minus 165 plus 80, which when we string all that together, we get 685 as our answer. And that is example 10.2D.